Hello friends. Previously we have created a part and assign material property to this part. Also we have learned that how to do a partition. So let's move forward. So let's click on assembly. Let's enter in the assembly module. We will create instances. So click on instance, click create, check on parts, and all the parts which we have created are listed here. So we have created one part, so here's one part. Please click on independent, uh, click apply. For this simulation purpose, I will have to create one more instance of this same part because of this nature of the simulation. So I will create one more part. Click on the auto offset from the instances and click on apply. Oh sorry, a part must be selected, so click on part and apply. So now we can see in the assembly module we have two instances of the same part. So we will try to assemble this. So let's try to move these two parts a little bit. So click on translate instances, click on this instance, click done, and now it asks to select a start point for the translation vector. Please select this point to what do I like? Click on this point. Click on OK. Now, since these two instances are identical, and they have we have placed them at the same place, so we are not able to see the difference. I will translate it further. So I will click the instance, I'll click done, and okay, the start point is 0 0 0, and then next point, let's say we will translate it in the z direction. So let's enter point 1, and then let's see what happens. We have translated a little bit. Let's create some more space in between these two. Okay, same procedure. Translation vector, click on this. Let's do a little bit more. 1. Now they are separated very well. Okay, so these two instances are parallel. Okay, so now in this module we will create some sets. Sets are very useful to handle with some coming modules. When dealing with the coming modules, sets will very helpful. So let's create some sets. surfaces and sets. So let's create some surface. So click on surface manager, click on create. Let's name it site surf 1. Select the region for the surface. Let's select a region. I will select this region and click on done. It will ask to the side because a surface has two sides. One side you can see purple side, and one side is brown side. So for this simulation purpose I will select this brown side. So click on brown side and we have created a surface. Create one more surface and name it side surf 2. Now this surface will be this one. Okay, now I want it to be facing side, so I will now click on purple because I want this side purple. So click on purple. We have created two surfaces. Let's create one more. Name it load surface. Click on continue. Now this time we will select this surface and this surface. By clicking shift you can select multiple items in Abaqus. Click on done. It asks to side, so I want facing sides, so flip one surface, flip this. Now browns are facing sides, so click on brown. So we have created these sets. Now we will place this instance back to the same place as it is. Click on translate, click on instance, click done, click on this bottom point and click on again this bottom point, and it is translated to the same place. So we have overlapped basically these two instances. Now we will move towards next step. Next module. So here this module is a step. So here we will create a procedure. Now we want dynamic explicit analysis. So dynamic explicit, we have to choose dynamic explicit. Click on continue. Please enter time period for 0.01. NLGO means nonlinear geometry, so it's a very large deformation process, so it should be on nonlinear geometry. Incremental mass scaling, others keep it default. Click OK. So we have created a step. Let's move on to the next. Let's move to interaction module. We will create a constraint to the seam. We will tie those seams on those surfaces, so when we inflate those the structure are sticked on the seams. So create constraint, create die constraint, name it whatever you want. Click continue, click on surface. So click on here surfaces which we have created, click on side surface 1, click continue, again choose slave surface, click on side surface 2, click continue. So keep all these things default. Click OK. So those seams have been tied together. Next module is load module. Here we will define loads. Click on load, then manager, create, name whatever you want. Click on step 1. This is step 1 is just we have created earlier in step module, so that is step, that means dynamic explicit step. Choose load. We have a list of loads, so we want pressure, so click on pressure, continue. Now it's asked to choose the surface where we want to apply the load, so click on load surface when we have created. Click on continue. Okay, so the pressure is uniform. Let's give some magnitude. Let's 1000 Pascal. Let's do some more. 10,000 Pascal. No, it says amplitude. Let's create an amplitude. Tabular data. Click on 0. Amplitude 0. Click on 0.0. The second time, so it matched to the earlier. In step time we have entered a time where incremental time, so time period. There we have entered 0.01. So I will do that same periodic time. I will enter here and I will amplitude enter 1. So the load will be factor of by this module. Select this, click on OK. So load has been created. Now see, let's again enter into the assembly module and then separate these instances to clearly see what's happening. Okay, now move around the next module in the load module. Look, the loads have been applied, the pressure applied internally to separate these two parts. The seam will be seam will be tied together, and this will inflate the structure. So let's go to assembly module and again translate it to back its proper place. Click on OK. Now let's we have done with load. Let's move to mesh. Click on seed, click on instances, select the part instance to be assigned, select all, approximate global size, click apply, OK, click on done. Next click on mesh, mesh instances, select the part instances, select all, done. We see that elements are quite big, so let's refine a little bit. Click on seed. Seeds are a way to control the refinement of the mesh. So let's decrease this to 0 1. Apply. Click on delete mesh. It's quite refined, so let's increase a little bit more. Let's 4. Okay, it should work fine. Click again, select all, click on done. Oh, let's refine a little bit more. So let's do 2, so it worked well. It's good. Mesh, create instances, select, and done. This is good. This looks good. Now we have meshed it, and in mesh we can control, select the region to be controlled, select. Here you can choose quad, terminator, and try. Basically this is triangle, this is quadrilateral with some reason triangular element. This Abaqus adjusts itself. In mesh you can choose element type, click on this, and here we have a standard, geometric, or linear, whether you want linear or quadratic. Quad, whatever you like. Okay. So now I will next move to job module. Let's create a job. Click on create, click on the model. Just we have created the model, name whatever you want, click on continue. Description, whatever you want to do, describe this model, click OK. The job has been listed here. Now let's do data check. So you can see the status here. That means it says us check has been submitted, check is running. So this status keep on changing until it was completed. You have to wait. So let's see when it is completed. It's do very quick check. Okay, now check has been completed. Now you can continue to, that means it was checking that all data is completed, all necessary data are there, and there's no missing out things. So let's do this. Okay, so let's submit it. Let's click on continue, and it will click on OK. The model has been submitted for analysis. Now you can click on monitor and see what's happening. So now the status has been changed to running, so the analysis is running now. Now that here the numbers are listing, as you will go on with the analysis, you will understand these things. So it is still running. Let's wait for some time to completed. Now, okay, it's completed. The status has been changed to completed, so dismiss it. And here you see completed. Now click on result and you will see results. Click on this icon, it will show you colored plot, contour plots. Now you see here. Let's move a little bit and see what happened to our model. Okay, let's increase these fonts. We see that bag has not inflated well very much. So let's increase some more loads. We can change it. We can go back to load module, choose load, click on edit, and let's enter one more 0. That means I am 100,000 Pascal load. Click OK. Dismiss it. Again go back to job. Let's submit it again. The status has changed to running. Now let's monitor it. Till now no number appeared. Let's see, it's show. Okay, numbers are appearing. Okay, it's going on. Okay, this has been completed. Again, let's check results again. Now you see it has just inflated more. So if you keep on increasing load, it will uh, keep on swelling, and you can refine mesh and do more analysis. So in the start I was saying that the realistic results, to get the realistic results you have to hit and try for more and more results. So if I keep on increasing loads, it will look like some, you know, more sophisticated shape. So let's do one more increase in the load. Click on create. Let's click 5 bar. That's 500,000, 5 times more. Click on job, click on submit, click on OK, and it's submitted. So you can see that you can go back and change some parameters and go come again, and in the job manager you can submit it again. So it's very easy to go back and change some parameter and come run again and see what's happening. So this is so you don't have to model again and again. So it's running. Let's monitor how far it has reached. Basically I see this total time, the period I have entered period 0.01 second, and it is going to reach to 0.01 second in a moment. It is reached. Okay, the analysis has been completed again. Let's click on result and click on OK. Now you can see it's swelling, it inflating more and more. So if you keep on increasing load, it will go on and on. So hope you have achieved what you wanted to learn, what I wanted to show through this demonstration. Please hit like, share, and please comment any question you want to ask. Please ask in the comment box, or you can mail me. uh, I will uh, I will give details in the in the description box. You can contact me if you want more. Thank you very much. Thank you for your presence again.